Okay, hello pre-calculus students once again. The first video that you saw was for secant graphing, it was just graphing the secant, and I gave you homework questions 1, 2, and 3. Again, we graphed the secant using the cosine function. The problem that I gave you though, it was the period was only pi, and then using the cosine, we just made the secant and made sure we had the asymptotes. We talked about endpoints, two endpoints, the midpoint, the Q1 and the Q3, which just visually is just clear cut and very obvious. Okay, so for this video, we're going to be doing solving some trig. You guys have seen most of this before already. However, we are going to add more concentration on factoring, solved by factoring. Doesn't mean every single one of these problems will be solved by factoring. Most will. There might be a question that's not solved by factoring, which means it's not factorable. Doesn't mean we can't solve it, it's just not factorable. So I'll probably throw one of those in there. I was thinking of doing two videos for this, two separate videos. I think it might be easier just do one longer video. So bear with me on this one. This one might be a little bit longer. So this will be the last video. So there's that one video on secant and this one video, which is a little bit longer. Homework questions on the back of this, and we'll be done. That'll be it for this week. Okay, so let's start off with something like this. By the way, every single thing that we're doing here is we're going to solve from 0 to 2 pi. The solution is from 0 to 2 pi. And remember, including 0, not including 2 pi, because, again, that's being redundant. All right? So just keep in mind, that's all that. Okay, so let's find x minus sine of x equals 0. Okay. Well, I can try something on this. I can try doing this, and I've seen people do this. This is a very important one because I've seen people do this. Okay, well, here's what I'm going to do. I'm going to move sine of x. I'm going to add sine of x over here. This is what I get. Sine squared x equals sine of x. Okay, well, now I'm going to divide. Yeah, I'm going to divide sine of x here. Okay, I'm going to divide sine of x here. I'm going to be left with sine of x equals 1. Great. Now I can find out sine of x equals 1. I'm going to flip it over. Let's see, where does sine equal 1? Sine equals 1 here. And that's it. So the answer is x equals pi over 2. Yay! X equals pi over 2. However, forgetting something here. If you look carefully at this, that may not be the only solution. Let's look carefully. So we got this. This may not be correct because I'm going to leave that x equals pi over 2. My guess is that that is a solution, maybe not the only solution. What you're going to have to notice is looking at this is you can factor it. Now, be specific here. What kind of factoring? They have a common factor here. These two terms do. That's why this is called GCF factoring. If I say GCF factoring, sometimes I refer to that as simple factoring. In Algebra 1, we do that. The greatest common factor, okay? So what do these two have in common? Well, they have a sine of x in common. And I'm going to open this up. This is going to be sine of x times sine of x to give us sine squared x, and then sine of x times negative 1 to give us 0. Now, why did I do that? I did that so I can do zero product property. This may yield more than one answer then. Let's see. So we have sine of x equals 0, so I'm going to write that out. Sine of x equals 0, and I have this one also. Sine of x minus 1 equals 0. Zero product property. I'm going to solve this. Sine of x equals 0. Well, let's see. Where does sine equals 0? Sine equals 0 where? Sine equals 0 here and here, which is going to be at 0 and pi. X equals 0 and pi. Okay. We'll also have this stuff. Plus 1. Sine of x equals 1. And that looks familiar because I thought we solved that one. Sine of x equals 1. That's right there. See? Sine is equal to 1. That's going to be pi over 2. Look at that. It's right over there. Pi over 2. So, by solving this by factoring, GCF factoring, we were able to get 1, 2, 3 solutions. 0, pi over 2, and pi. As opposed to not factoring it and just solving it algebraically like that, you'll notice you'd only get one solution. So this is the correct way of doing it. It's called GCF factoring. Okay, let's move on to a different type of problem. Okay, I'm going to erase it. I'm going to look at it through the lens of what Okay, how can I factor this? I'm going to look at it through that lens. So let's look at this problem. Sine squared x minus 1 equals 0. Okay, sine squared x minus 1 equals 0. Okay, I'm going to take this as just kind of a simple. I'm not going to think about factoring necessarily. Because if I look at it just carefully, and I'm just going to like, well, GCF, these things don't have anything in common. This has sine, this one doesn't. The x, this one doesn't. So I'm just going to say, yeah, they have nothing in common. I cannot factor this thing. Well, I know for sure I can't GCF factor it. So I'm just going to do this. Let's try this out. 1 plus 1. Sine squared x equals 1. Then I'm going to square root both sides. Sine of x equals plus or minus 1. Perfect. Then I'm going to say sine of x equals 1. Sine of x equals negative 1. And I'm going to see where does sine equal 1 and negative 1. Let's see. Sine is 1 at pi over 2. And it's negative 1 at 3 pi over 2. So we got it. Oops, did I break this thing? No, okay. Pi over 2 and 3 pi over 2. Let me oh crap, I think anyways, whatever. Okay, so pi over 2 and 3 pi over 2. Yay, great, awesome. I'm going to leave those alone for a second. Now I'm going to do this as a different method. Though that seemed okay, and it very well might be okay, I'm going to ask you a question here. I'm going to say, well, can we factor it? And if so, how do we factor it? If I were to give you something like this, guys, let's go back to algebra. You'd probably say, oh, well, yeah, Mr. Arnold, that can be factored. Well, how? X method, diamond method? Well, yeah, it can, but if you've taken enough algebra and algebra 2, you know off the top of your head, this is a difference of squares. It's going to be x plus 3 times x minus 3. You can set that equal to 0, zero product property. X will equal to negative 3. X will equal to positive 3. You're done. That's the same thing. Let's take a look at it. This is the same as saying it's a difference of squares. So sine of x plus 1, sine of x minus 1. Here. Don't believe me? Here, I'll work it out for you. I'll do it in different colors so that I could erase it later. If you don't believe me. Sine of x times sine of x is sine squared x. Sine of x times negative 1 is negative sine of x. 1 times that is positive sine of x. Positive 1 times negative 1 is negative 1. Cancel out like terms. You're left with sine of x, sine squared x minus 1. Same thing. Okay? So this was a difference of squares is essentially what it was. And there's the proof. Okay, so I'm just going to go back here and I'm actually going to solve it. Let's solve it. Zero product property again. Cover this up, solve it. Cover this up, solve it. Let's do this. Sine x plus 1 equals 0. Sine of x minus 1 equals 0. And if you'll notice, I'm basically ending up with sine of x equals negative 1. Sine of x equals positive 1. This will yield that answer. This will yield that answer. Simple. I just look, where does the sine equal to 1? Right there. Where does the sine equal negative 1? Sine of what would equal to negative 1? And that would be right there. So it's essentially the same thing. However, the difference is, yeah, but Mr. Arnold, I like doing it the other way, the previous way you did. That's great. But I want you to know that you can also do a difference of squares. I want you to notice that, okay? Because certain problems you might only be able to do it using difference of squares, and that method may not yield all the answers, okay? So moving on to the next one. Let's try something like this. Even pause the video when you get to it and try to see if you can figure out how this is being factored. Okay, let's try this. Square x minus cosine x equals 0. Okay, so think about how we can factor that. It is factorable. I'll tell you that much right now, but how can we factor this? Well, you ready? Let's do this. It's not a difference of squares, no. It's not a trinomial, but I do see that I got cosine of x on both. But not only that, they both have at least the greatest common factor, GCF factoring, is going to be cosine squared x. That's going to be times 1. That's going to be minus, I need another cosine of x. And we're left with the same thing. We do the same thing. We just do zero product property. So let's write the first one out. Cosine squared x equals 0. And the second one we're going to do is 1 minus cosine of x equals 0. Let's do this one first. Square root, cosine of x equals 0. And where does cosine equal 0? It hasn't broken already. Okay, where does cosine of x equal 0? Cosine must equal to 0. That's a no. That's a yes. And that's a yes. Cosine of x equals 0 at what? Let's see. Pi over 2, 3 pi over 2. Pi over 2 and 3 pi over 2. Next, let's solve this. Minus 1 minus 1. Negative cosine of x equals negative 1. Divided by negative, we're left with cosine of x equals positive 1. So, where does cosine equal 1? All right, let's see here. Cosine equals 1. Yes, right there. And that's it. So, cosine equals 1 at 0 only. So, we got x equals 0. So, we have here 3 solutions. Pi over 2, 3 pi over 2, and 0. Okay, we did GCF factoring there. All right, moving on. We're almost done. So yeah, it looks like this is going to be about a 15-minute video or so. Sorry, this one's a little bit longer, but I just thought I could just finish it off in one more video. Okay, let's try out this one. 1 plus sine squared x equals 2 cosine squared. Oh, sorry, this is 1 plus sine of x. I'm sorry, I did that one wrong. 1 plus sine of x equals 2 cosine squared x. Yeah, don't waste your time. You can't factor that. Not factorable. But it's okay. We don't have to factor it. We can still solve this. Now, how are we going to solve this? Well, I see here, this is the method I like. This is the way I like to think about it. I see a sine of x here. I see a cosine there. A sine here, cosine here. Doesn't jive well with me. However, we are going to look at, now this is maybe the exact copy of your cheat sheet that you have, but we are going to look at the Pythagorean, the Pythagorean identities. Okay, I know it's hard to see. And for the Pythagorean identities, if I look at it, I see sine squared x, or theta, doesn't matter, plus cosine squared x equals 1. Well, okay, I have a cosine squared x here. That 2 is in the way. So here's what I'm going to do. I am going to just figure out what cosine squared x is. So let's do this. I'm going to subtract sine squared x here. Subtract sine squared x. Okay, and I'm left with cosine squared x equals 1 minus sine squared x. That's what cosine squared x is. So here's what I'm going to do. I'm going to go here and I'm going to replace cosine squared x. I'm going to substitute it with that. 1 minus sine squared x. Okay. Erase this. So if it helps, I'll write the original up here. 1 plus sine of x equals 2 cosine squared x. What we essentially did is we substituted cosine squared x with 1 minus sine squared x using the Pythagorean identities. Okay, let's work it out. 1 plus sine of x equals, I'm going to multiply this, 2 times, and then 2 times that is going to be negative 2 sine squared x. Okay, let's continue working this out. What else can we do? We can do, let's see, we can go minus 2 here. I'm just algebraically just kind of working it out. Doesn't really matter. I'm going to go minus 2 here. Negative 1 plus sine of x equals negative 2 sine squared x. Okay, great. Why don't I move that one over? I'll move this guy over. So I can set it equal to 0. Maybe that'll work. So I'll have plus 2 sine squared x plus 2 sine squared x. I'll be left with 2 sine squared x plus sine of x minus 1 equals 0. Okay? See what I did there? Now what can I do? Now, here's the key here. If you look carefully, you may notice that I have a trinomial. If I were to give you something like this in algebra 1, 2x squared plus x minus 1 equals 0, and I said, okay, try to factor that. You would say, okay, let me try to do it. A times c, x method. A times c is negative 2. This is 1. What multiplies to give us 2? 1 times 2. And then let's see here. This would have, well, who would have to be a negative? That would have to be a negative. But then you have to divide this whole thing by 2. We divide by the a. Divide both of them by 2. That'll give us 1. That'll give us just negative 1 over 2. And the way you write that would be x plus 1. And this would be written as 2x minus 1. 2x minus 1. All equals to 0. This is x method factoring of a trinomial. Now you may say, well, what the hell does that have to do with that? Guess what? It's the same thing. This is the same exact thing. 2x squared isn't that the same? I can write that as 2 sine squared x plus sine of x minus 1. So this can be broken down into this. The way I can write this is this. 2 sine of x minus 1. So look at this. 2 sine of x minus 1 times sine of x plus 1 equals 0. How does that help me out? Because now I can just do a zero product property. Sine of x plus 1 equals 0. That'll be minus 1 minus 1. Sine of x equals negative 1. That's what you're going to get. You get sine of x equals negative 1. Flip it over. Get the unit circle. Where does sine equal negative 1? Okay, so let's actually do that. So I'm going to erase this top so we actually work that one out, okay? So I'm going to erase this top one. Hold it. And we're going to finish that part up. So this zero product property in this is going to give us two things. 2 sine of x minus 1 equals 0. And it's going to give us sine of x plus 1 equals 0. We're going to solve them separately. I'm going to solve this one first. Minus 1, minus 1. Sine of x equals negative 1. Where the sine of what is negative 1? Sine of what is negative 1? Sine of what is negative 1? Here. That is 3 pi over 2. Great. Done. Let's solve this one now. Plus 1, 2 sine of x equals 1. Divide by 2. Okay, where the sine of what is 1/2? Where does the sine equal 1/2? 1/2. Oh, here? Let's see, where else does the sine equal 1/2? Right there. That's it. So where does it equal 1/2? Pi over 6, 5 pi over 6. And there we have it. We have 1, 2, 3 solutions. Pi over 6, 5 pi over 6, 3 pi over 2. That seemed heavy. That's okay. Here's what we're going to do. We are going to do one last question similar to that. That has to do with factoring because I know this is a little bit heavy. So we're going to do one more question like that, okay? A factoring one. One seems a little bit heavy. So I'll do another one like that, similar to that, so we can get this done with. Okay, so last problem here. We have cosine squared x minus 2 cosine of x minus 3 equals 0. Okay, a couple things that are easy about this. It's already set up. It's in standard form. A, B, C equals 0. Boom. It's a trinomial ready to be x method. Let's think about it. A times C goes up here. B goes down here. A times C. A coefficient here, C coefficient here. So do you guys kind of notice this is a trinomial? A is 1, C is negative 3. A times C is negative 3. Our B is negative 2. So let's figure it out. How do I get negative 3? Well, I get 1 times 3. Who has to be negative? It has to be the negative 3 here. Normally, I would divide by our a, but since our a is 1, it doesn't really matter. It's not going to change anything. That's it. We factored it. Well, we did x method factor. So now we actually have to write this out. So I'm not going to write x plus 1, x minus 3. Well, I'm going to write it based off how I have it. So I'm going to put cosine of x plus 1, cosine of x minus 3 equals 0. Now we have zero product property. Let's do it. We can do zero product property. Let's do this one first. Cosine of x plus 1 equals 0. And then this one right here, cosine of x minus 3 equals 0. Well, that one, well, we'll get to that soon. Minus 1, minus 1. Cosine of x equals negative 1. Flip it. Cosine of x equals negative 1. Cosine negative 1. Cosine, that's the only one. Cosine negative 1, that is at pi. Okay, great. We got a solution. Let's test this one out now. Plus 3, plus 3. Uh-oh. Uh-oh. Cosine of x equals... Uh-oh. What? Where does cosine equal 3? It's not gonna. The highest it goes to and the lowest it goes to is 1. Yeah, I mean, the highest I can get to is 1 for cosine. The lowest I can get to here is negative 1. It's not even going to go to 3. It's not within my parameters. It's just not going to happen. Not within my parameters. Not within these parameters. So this one's going to yield no solution. So the only solution here would be pi. X equals pi. I know that was a lot for one video. I'm going to flip this over now, and you're going to get, you had problems 1 through 3 for the secant graph. Now we have 4, 5, 6, 7, 8. 5 more problems here. And again, I want you to factor it, solve by factoring when possible. Okay. If you solve by factoring, you're always going to get the full solution set. However, there may be a problem here that's not factorable. So either way, it doesn't matter. Just solve it still. Okay. 4, 5, 6, 7, and 8. So remember, video 1 and video 2, this is video 2. Video 1 and video 2 together, we have 8 problems. Separate sheet of paper. You'll see the assignment available, I don't know, tomorrow, sometime today. Today is Tuesday, or tomorrow. Whenever it's available on Schoology, you just upload it. Okay? And then you'll also get the practice test on Wednesday. All right, see you guys.